Alright, this is just a quick example problems for how to use the transformer equation. So let's say that we have a transformer is made to convert 20 volts AC to a higher voltage. The current in the primary side was found to be 6 amps, and on the secondary side it was 2 amps. Calculate the secondary voltage as well as the secondary number of coils if there are 50 primary coils. So one of the first things we're going to do is write out the given information, VP, so our primary voltage. So it's basically, we can see here, you're trying to convert this to something higher. So this would be our 20 volts. Our secondary voltage is the unknown higher voltage that we want. It says here that the primary current was 6 amps and the secondary current drops to 2 amps. Well, if the current is dropping, the voltage must go up. Remember, the two are reciprocal to each other. There are 50 primary coils, and we need to figure out the ratio, basically what the secondary number of coils is. So the transformer equation, I'll write it out, is VP over VS equals IS over IP. Notice the reciprocalness of this. And then we have NP over NS. For the first part, I'll put in the numbers here so you can kind of see that we're working with ratios. Really, it's the easiest way to think about it. So if we have 20 volts over Vs equals 2 amps over 6. Now you can clearly see that with this, I'll put a 50 over Ns. What you can see here is that we just have a ratio of 1 to 3, right? 2 to 6 is the same as 1 to 3. So that means that if this goes up by 3, so you can say, 6 divided by 2 is 3, so 2 times 3 is 6. I don't know how many ways I can do this. So it's basically going up by a factor of 3, then this must drop this 2 must go up by a factor of 3. So you can see the secondary voltage must be 3 times bigger than the primary voltage if the current drops from 6 down to 2. So we know basically, since that factor is 3, that our Vs, which must be bigger than 20, it's going to go up to 60. So we can see that even without doing any, mathematics, if you will, we can see that. Or we can cross multiply. We can see that what we're going to end up with here, if we isolate for Vs, we are going to end up with 20 times 6 divided by 2, which is exactly what we said, 20 times 3, which is 60 volts. So I mean, you can think of it as ratios, 1 to 3 ratio, or you can actually do cross multiplication to get the result. So again, that happened because the Vs went up here, the 2 comes down here, and then 20 times 6. So we can see that that's what we get. For the second part, what we're gonna have on the other side is this here, and we have NS. So again, it's 1 to 3. So if this goes up by 3 times, this has to go up by 3 times. So we know that our secondary number of turns is going to be 150, because it's just 3 times 50. So that's 50 times 6 divided by 2. Use cross multiplication. And that just tells us that it's 50 times 3 once again. And so that's going to give us 150 turns. Again, it's a step up transformer, right? So we know that the number of secondary turns must be more than the number of primary turns. So it had to go up. So in order for the power to be the same, if we have a step up transformer, okay, versus a step down, right? Then what we know is that the secondary voltage is bigger than the primary voltage, and the secondary current is less than the primary current. For a step down transformer, secondary current is less than the primary current, and the reciprocal is that the current is bigger on the secondary side. And the main key point is that power on both sides is the same. The law of conservation of energy says that has to be true. Okay. Calculate the power on both sides. Well, to double check that this is correct, we know that the power on both sides better be the same. So on the primary side and on the secondary side, we had VP was 20, IP was 6, VS was 60, IS was 2. 20 times 6 is 120 watts of power. 60 times 2 is 120 watts, joules per second. These are the same. And that's a good check to see if you've done the question correctly. If you check the power on both sides, you can actually check that if the power is the same on both sides, you can actually check that you've done the question correctly. You could have also alternatively used IP squared RP equals I squared SRS. Sorry, you can't use this in this case, but if we were asked to find out what the resistance is on either side, we could actually use this formula to figure out the resistance. Or we can also use this. And that's something that we'll see in the next question. That don't forget that we know Ohm's law and we know the other power equations for anything that results in us having to use the resistance. Okay, calculate the resistance in each of the coils. Well, like I just said, let's look at this the primary side. So on the primary side, we know that the primary voltage is given like this. So the primary voltage, I believe, was 20. The primary current was 6. And so we can find that resistance. So it's going to be RP is 20 over 6. It's approximately 3.3 ohms. You could have also done this using the power is equal to IP squared RP, like so. And we know the power is 120. We know the primary current was 6. And so what we end up with is RP is 120 over 6 squared, which gives us exactly the same result of approximately 3.3 ohms. Okay, so it doesn't matter which equation you use, it will work. So to find the secondary side, so for the secondary side, we would just say, I don't know, I'll pick the power on the secondary side is the current on the secondary side squared, like so. So 120 is the same as the power on the primary side. Remember, that's a key point. Divided by 2 squared. So RS is approximately 120 divided by 2 is 60, divided by 2 is 30. So that's the same thing as saying 120 divided by 4 or 120 divided by 2 squared. So you end up with 30 ohms. So primary side had 3.3 ohms and the secondary side had 30 ohms for the resistance. And notice the subscripts are really important, don't forget those. Okay, so now what you can do is you'll be able to work through these questions here, questions 1 through to 6. That's what you're required to have done by the end of class, not today, but tomorrow. And we'll work on it a bit in class tomorrow, as well as another activity.